Hello everyone, welcome to our group presentation. My name is Christine Jean-Louis and my student ID is 109305056. I'll be presenting on the first question. So the first question is basically about the rule of 70, which states that an amount will double in approximately 70 over X years. Now, let's assume that we have the current income, which is Y0, and the annual growth rate is X%. And this annual growth rate is compounded continuously. Let's show the equation showing the income level in T years, and then we will prove the rule of 70. So the equation can be written like that. A equal to Y0, which is the initial income, time E, which is the mathematical constant, E, and to the power of RT. R is the annual growth rate, and it is expressed as X over 100, and T is the time in years. So this is the equation for the showing the income level in T years. Now let's try to prove the rule of 70. So we state that A equal to Y0 E over RT. Now let's suppose that A in T years will equal to 2Y0. Now, if we replace 2Y0 into the equation, so we will have 2Y0 equal to Y0 E to the power of RT. And if we cancel out Y0, we will have 2 equal E to the power of RT. Now, let's take ln for both sides. We'll have ln 2 equal to RT. And if we try to find T will equal to ln 2 over R. Now, as we said, R is expressed as X over 100. Now, if we replace X over 100 into the equation, so we'll find that T equal ln 2 times 100 over X. And finally, T equals 69.31 over X, and approximately T equals 70 over X. So this is the rule of 70.
Hello everyone, my name is Christina. My student ID is 110305046, and today I'm going to present the second question, which is about macroeconomics. So in this questions, we have a cost function which is estimated to be 1.15x plus 6,000, which is right here. So the first thing we needed to calculate is the fixed cost function. So here we have FC equal to 6,000. We secondly needed to find the variable cost functions. So we first have the variable cost, which is 1.15. So the variable cost function is equal to 1.15x. And third, we needed to find the marginal cost. So the marginal cost is the first derivative of the cost function. So that is why the marginal cost is 1.15. Secondly, we had to find the average fixed cost. So average fixed cost is basically the fixed cost over X. So this is why we have average fixed cost equals to 6,000 over X. And the average variable cost, it's also the variable cost divided by X. So since the variable cost function was 1.15x, so 1.15x over X, we found that the average variable cost is equal to 1.15. And lastly, we needed to find the average total cost function. So average total cost is equal to total cost divided by X. So since the total cost was 1.15x plus 6,000, so basically the average total cost is equal to 1.15x plus 6,000 over x. And in the third part, we needed to find the different asymptotes. So these asymptotes, we need to find them based on the average total cost functions, which we have over here. And the domain is basically the every real numbers except x equal to 0. So as for the horizontal asymptote, we took the limit of the average total cost function as x approaches infinity, and we found 1.15x over x. So the horizontal asymptote is equal to y equal 1.15. So this is the horizontal asymptote. And as for the vertical asymptote, we also took the limit of the average total cost function, but this time as x approaches 0. And as we can see it here, as x approaches 0, the average total cost function is approaching infinity. So the vertical asymptote, it's basically x equal to 0. And lastly, or in the fourth position, we needed to draw the average total cost function, the average variable cost function, and also the marginal cost curve. We needed to draw all of them. So right here, we have the x-axis, and then we have the y-axis. Remember, x equals to 0 is the average, is the vertical asymptote, and y equal to 1.15 is the horizontal asymptote, which we have over here. And because we found both average variable cost and marginal cost equal to 1.15, so we also have them right here. And then right here, we have the average total cost function, which we can see is decreasing as x is increasing. So to have a better view of that, right here we have it better design, better drawn. So we can see that the average total cost function is decreasing as x is increasing. And as for the average cost or marginal cost, it stays constant at 1.15, and because both average variable cost and marginal cost are equal, so basically the blue line represent these two factors. So based on the graph we saw just now, we want to know, is the firm experiencing economies of scale, or can it be a natural monopoly? So first of all, we can conclude yes, that the firm is experiencing economies of scale, just because as we can see it, total cost is decreasing as the quantity x is increasing. So this is why we can say that this company is experiencing economies of scale. In other words, the more output the company produces, the less costs this company will endure. So yes, the company is experiencing economies of scale. And can it become a natural monopoly? We also think yes, because of the reason mentioned above. First, in this industry, there is a lot of very high barriers to entry, because if you are producing low output, you will incur very high cost. So a new player will really enjoy a lot of huge cost if it were to enter this new market. So this firm, because it is experiencing now economies of scale, it can be considered as a natural monopoly. And also the second reason is the economies of scale advantages that we mentioned just now. So based on these two reasons, we can say that this company is experiencing, can be a natural monopoly just because it is experiencing economies of scales among others. So thank you, and now we're going to move on to question 3, and my teammate is going to take care of that.
大家好，我是107208003的李承勇，然后由我来讲解第3跟第4题。那第3题基本上是在说一个公司制造了一个新的产品之后，通过投放广告，并且人们观看广告数量的多寡，然后决定多少观看人群比例去购买这个产品的一个函式。那函式如下首先第一题 那基本上它的意思是，多少比例的人会在完全没有观看广告的状况下购买这个产品？那没有观看广告，可想而知，那 T 就会等于0嘛。那所以这个就是把 T 当做0代入，那基本上经过计算之后会得到一个4%的数字。那这就是第一题。那第二题是找到 the rate of change， 然后对 P 做微分。那基本上就是对 P 这个函数去做微分。那我是用连锁率去计算，是用乘法的连锁率去计算，然后我用乘法的公式去算的。那基本上首项微分乘上第二项加上首项乘上第二项的微分。那首项的微分是0，因为100%的微分是0，所以我们就不计算前面首项微分乘上第二项，那就直接进到首项乘上第二项的微分。那经过微分之后的函式就会变成如上图所示。对，那我并没有把它乘开，因为乘开之后非常的丑。那第三题是希望要画出这个函式的图形。那基本上我觉得如果要让这个函式有意义的话，观看的人是不可能为负，因为没有人看就是没有人看，所以我认为 t 应该要大于等于0，所以我并没有去做复数的函数图形的绘画。那基本上假设 t 大于等于0，在 t 等于0，也就是没有人观看的时候，购买的人数比例应该会是在4%，这是第一题得到的答案。那假设当 t 趋近于无限多的人观看过后，那p 这个函式的极限应该要接近于100%，因为后面的那个当 t 代入的话，后面会变成0，那基本上就是100% 乘上1，那基本上就会趋近于100%。对，那这就是第三题，所以它会是一个快速成长，然后慢慢趋近于100%的一个曲线。好，那第四题是讲有一个电脑公司同时有两个计算器，那基本上它有2个需求曲线。那就需求曲线如下图。首先第一题是问说这2个计算器之间的关系是什么，并且用微积分来解释。那这2个计算器的关系应该是为替代品的关系。那用微积分来解释的话，就是通过对于2条需求曲线各自对另外一项的价格做偏微分之后，可以发现，两个微分之后所得到的数值皆为负数，那代表其中一方的价格上升，也会造成另一方的需求也跟着上升。那因此这个东西会是一个替代品。对，所以基本上会确定这2个人为替代，这2个东西为替代关系。那第二题是要找到一个总收入的 function。那总收入顾名思义就是第一项计算器的销量乘上价格，加上第二个计算器的销量乘上价格，那就是 P1 乘上 Q1，那就是把 Q1 代入，然后就会是如下这个式子。那一样我没有把它做一个整理，对，我没有想要把它弄得非常丑的意思。那第三题的话，就是当在P1 等于多少，P2 等于多少的时候，应该要是最高的 total revenue，那最高的收益，那应该就会是这个这个曲线的 critical point。那我们就是对各自对 P1 跟 P2 都做一次偏微分，然后得到式子，然后去计算得出 P1 跟 P2 的 得出 P1 P2 得出偏微分之后式子，然后经过整理运算之后可以得到P1 的价格应该是5 ，P2 的价格是3。对，第4题，那他问的意思是需要有多少的单元应该要被产生，那就把 P 带进 Q1、Q2 的式子里面，那可以得出 Q1 等于39，Q2 等于33。那最后一题就是问，那最高的所得数字应该是多少？那很简单，就是把 P1、Q1、P2、Q2 全部带进去，那最后得到的是294。那这就是第4题的部分。那最后第5题由我的队友继续。
Now I'm going to present about the 5th question. So the 5th question is about the Cobb-Douglas utility function. So the first thing that I will do is let's assume that we have 2 commodity X and Y. I'm going to show on a curve some combinations of the commodities X and Y, while both of them, these combinations, they are restricted to only be 6. Now let's take a look at this. Let's take a look at this one. So let's say we have, as the function is defined, x to the power of 0.5, y to the power of 0.5, and it is restricted to be only 6. Now, if we take out the power, we can find that x and y equal to 36. So x will equal to 36 over y, and y will equal to 36 over x. So there are multiple combinations that we could do. And as you can see here on the curve on the left, we can see that there are some combinations such as x equal 1, y equal 36, x equal 4, y equal 9, and x equal 36, y equal 1. So these are all combinations of x and y that would satisfy the restrictions of u of x, y equals 6. Now, what do we call the curve, this curve on the left in economics? So in economics, it is called an indifference curve. So an indifference curve is a curve on which there are a lot of combinations, and all of these combinations, they have an equal satisfaction of utility for the consumers. For example, if someone chooses bundle A or someone chooses bundle B here, or bundle C, which is 36.1, they'll still have the same utility and the same satisfaction. Now, how do we define the marginal rate of substitutions, MRS XY? Well, the marginal rate of substitution is the marginal rate of substitution is the rate at which a consumer is willing to give up some quantity of good X in exchange of good Y, while maintaining the same level of satisfaction of utility. So as we can see in the previous graph I just showed, so if someone give up some of good X to gain more of good Y, and vice versa, if someone give some of good Y to gain some more of good X, so this is what we call the marginal rate of substitution. Now, it is defined in mathematics as the negative of the ratio of the marginal utility of good X to the marginal utility of good Y. So the marginal utility of good X is defined as MUX, and the marginal utility of good Y is equal as MUY, and we can see that MRSXY is equal to the negative of MUX over MUY. Now, what is the marginal utility function of commodity X? So the marginal utility function of commodity X is the partial derivative of the utility function with respect to X. Now, MUX equal the partial derivative of U, which is the utility function, over the partial derivative of X. And equally, the marginal utility of function of commodity Y is the partial derivative of the utility function with respect to y. As you can see, the MUI equal the partial derivative of u, which is the utility functions, over the partial derivative of y. Now, how can we are going to try to prove that MRS, which is the marginal rate of substitutions that we just explained earlier, is equal to the negative of marginal utility of x over marginal utility of y. Now, to prove that, we are going to use implicit differentiation. So how do we use implicit differentiation? We use it to differentiate the z function. We will just let z be the utility function of xy. Now, when we use the implicit differentiation and for the partial derivative,
now we can see that dz over dx equal to partial derivative of u over partial derivative of x times dx over dx plus partial derivative of u over partial derivative of y times dy over dx.
Now, let's take the case where z equal to the utility function xy equal to a constant c. Now, this constant for example, can be 6. So when we have z equal to the utility function of x and y equal to 6, so this implies that when we take the derivative of the constant, this implies that the partial derivative of u over partial derivative of x plus partial derivative of u over partial derivative of y times dy over dx will equal to 0. And now we want to know what is the value of dy over dx. Now let's consider that partial derivative of u over partial derivative of y would be different from 0. Then dy over dx will equal to the negative of partial derivative of u over partial derivative of x, which is mux, over partial derivative of u over partial derivative of y, which is mui. So basically, this equal to the marginal rate of substitutions that we just mentioned earlier. So now let's just do a practical example. Let's say MRS equal to, let's say we want to calculate the MRX xy at 3 when x equal to 3 and y equal 12. So if we take the negative of mux over mui, as we can see, mux in this utility function will equal 0.5 x to the power of negative 0.5 y to the power of 0.5, and the marginal utility of y will equal 0.5 x to the power of 0.5 y to the power of negative 0.5. Now we can see that MRS xy will finally equal to negative y over x. Now, considering that x equals 3 and y equals 12, then the MRS of 3 and 12 will equal negative 4. So this is it for our presentation. Thank you all for watching.